Jai Hind everyone. So again I welcome you to the lecture series of Basic Electrical Engineering. Now in today's lecture I am going to discuss about the fifth unit, and this unit is related to the electrical installations. So in this particular unit today I am going to cover the contents that are related to LT switchgear. Here LT stand for low tension. So the voltage level, it is generally below 11 kV, so it is called LT switchgear. Now in this, various controlling or the protecting devices that can be used are: the first one, switched fuse unit, that is commonly known as SFU. The second one is miniature circuit breaker, that is commonly known as MCB. The third one, it is molded case circuit breaker, it is commonly known as MCCB. And the last one is earth leakage circuit breaker, so it is commonly known as ELCB. So let us first discuss what do we mean by LT switchgear. So the apparatus that is used for switching, controlling or protecting the electrical circuits and equipment is known as switchgear. So this term switchgear is a generic term that encompassing a wide range of products like circuit breakers, switches, switch fuse unit, offload isolators, HRC fuses, contactors, earth leakage circuit breaker, etc. So there are n number of protective devices that are used in electrical industry, but we will limit our discussion up to the four topics that I have recently discussed. So the first device that is generally used, it is called switch fuse unit. Now I hope all of you might have seen this type of box in your day-to-day life. So around a decade ago, this was quite popularly used, but now these type of SFU, they are being obsolete. But to understand the basic working of protection, these are the elementary one which were previously used. So let us start with this SFU only. So as you can see here, in this white portion, it is also called the KitKat. So here inside this particular KitKat, we generally have a wire, that is a fuse wire. So it is a reusable wire. We always, whenever the current it exceeds its limit, so this particular wire, so it will, that is called the fuse wire, it will blow up and it will disconnect the supply and the load. So thus it will protect the load from any unwanted situation like overcurrent or any faulty situation, that is the short circuit condition. So here as you can see, we have one lever. So with the help of this particular lever, we can switch on and switch off this particular box. So it is generally called as switched fuse unit. So the basic purpose of this switch fuse unit is that it has one switch unit and one fuse unit. When it is operated, the contacts will get close through the switch and the supply will pass through the fuse unit to the output. Now this switch fuse unit, they are generally used for distributing power and protecting electrical devices from damage due to fluctuation. So this fuse unit is housed in an enclosure that is generally made up of steel sheet. So you can see here the outer box, it is generally made up of steel because it is almost corrosion free. So it provides that particular protection to this particular protective equipment, that is the KitKat. Now we know that this particular SFU nowadays, it is obsolete and it is generally replaced by a electrical device that is called MCB. So the main disadvantage of this particular SFU are: the first one is that every time that particular fuse wire will melt, then we have to replace it with a new one. So in the suppose night time, now it is very difficult to locate that particular wire also. So that is one limitation. Second thing is that again you can see there are various KitKats, and by simply looking at these particular KitKats, we will not be able to locate in which particular line the fault has occurred. So first we have to remove a single KitKat each and every time. So again this process is quite cumbersome. It will take a lot of time. So that is also the demerit of this. So due to these particular demerits, we generally now don't use this type of SFU, and in your home or in industrial applications also, you might have seen these particular fuses. Now they are replaced either by MCB, that is very popular for household purpose, and MCCB, that is more popular in case of industrial applications. So now let us discuss about the second protective equipment. So it is called MCB. So MCB stands for miniature circuit breaker. So a miniature circuit breaker automatically switches off electrical circuit during the abnormal condition like your overload condition or as well as faulty condition. So by faulty condition we mean it may be the short circuit condition. So nowadays we generally use MCB for low voltage electrical network instead of the fuse. So as I told you that basically due to the demerits of these fuse, now they are almost obsolete, and we generally prefer this MCB over the fuse. So the fuse may not sense it, but the miniature circuit breaker does it in a more reliable way. So sensitivity is also more in case of MCB also, so it can provide a better protection as compared to the fuse. And next thing, as I told you, the handling of this fuse, again it is quite a tedious task. Now to overcome this, the handling of MCB is quite safer as compared to the fuse. Like you might have seen at your home also, when we use this MCB, suppose any fault occurs in any of the line. So simply by looking at the board, you can trace which particular MCB has been tripped, and you can restore that particular supply with the help of simply pushing that particular knob in the on position. So the quick restoration of the supply is possible in case of this particular MCB as compared to the fuse. So because of these particular advantages, we generally prefer this MCB over the fuse. Now coming to the working principle of this particular MCB. So in this particular picture, you can see the picture on the right hand side. It shows the casing of this particular MCB. This type of MCB, when you go to purchase this MCB, so this MCB looks like this. So as you can see here, this is again a molding in which you will find different parts that are shown on the left side of the picture. So here in this you can see one jack is there, like here you can see this particular lever. So this can be used for on off condition, and with that again we have this magnetic relay that is also present here for overloaded condition, and with that we have this is your bimetallic strip. Again this is used for protection under overloaded condition. So basically this is the construction of an MCB. Now how this MCB work, let us see here. So as we know that the basic function of this MCB, it has to provide protection first for the overload condition and second for the faulty condition, that is also known as short circuit condition. So for overload protection, we generally use the bimetallic element. So as you can see here, this bimetallic strip is shown. Now what happens under the normal condition, when the current is under the prescribed limit, this particular bimetallic strip it will remain straight and it will not make any contact with the latch here. So what will happen, that this particular circuit will remain in closed position. So that means the current will flow from the supply to the load. Now as soon as there will be an overloaded condition, so under that particular condition, this bimetallic strip, as it is made up of two metals, so one portion will have different expansion as compared to the second portion. So due to that, this particular strip will bend. So when this particular strip will bend, it will make contact with this particular latch and this particular contact will be opened. So when this particular contact will be opened, now that means the supply has been disconnected from the load. So this is the way by which we can provide overload protection. Now the second protection is provided by this particular magnetic circuit. Here you can see we have a coil and here we have a plunger. So under faulty condition, we know that whenever the short circuit happens, the current increases tremendously. Okay, so within a very few time period, the value of the current will increase to abnormal conditions. So under that particular condition, we can't wait for this particular bimetallic strip to bend. So it will take some time for this particular bimetallic strip to bend and disconnect this particular contact. So if that thing will happen, in that situation, there are chances that our load will also get damaged. So that protection has to be very fast. That means for the faulty condition. So that's why we have provided this second type of protection for the faulty condition. Here you can see this is the coil. Now again, what happens under the normal condition, this particular plunger, it will remain its initial condition and this particular contact will remain closed. So as soon as the value of the current in this coil, it increases exponentially. So what will happen, this particular coil will act as a magnet and it will pull this particular plunger towards itself. So when this particular plunger will get displaced, again you can see here this contact will get opened. So this operation is very fast as compared to the first type of protection, that is using a bimetallic strip. So that's why for overload condition, we have provided the first type of protection with the help of bimetallic element, and for the second overloaded condition, we have provided protection with the help of this coil. So in this way, we can protect our equipment, whether it is your refrigerator, whether it is your washing machine, all the electrical equipment that you are using at your home, you can protect it with the help of this MCB. Now the next protective device, that is called MCCB. Now MCCB, I generally call this MCCB as the big brother of MCB. So the reason is that the most of the features of this MCCB, they are similar as we have discussed in MCB, like it is also used for your overload protection and secondly for the faulty condition. But the major difference is that MCB, it is generally used for lower current rating. So it is generally used for household application. Whereas this MCCB, it is generally used for industrial application. So it comes with a wide range of this particular current ratings. So that's why this MCCB, it is more or like in operation like MCB, but the only difference is that the current capacity of this MCCB is better. And the second thing is that it has some more features that are not present in MCB. So first let us discuss what is this construction of this MCCB. Now here you can see the MCCB, it is generally have a thermal element for again overcurrent protection and again a magnetic element for short circuit release, which has to operate faster. So these two features, they were also present in case of MCCB. So MCB and MCCB, they work in the same manner for this overcurrent as well as the faulty condition. So the major components of this MCCB, they include first again a mechanism which makes and breaks a contact through a toggle link mechanism having a spring which can store tripping force. So you might have seen at your home also, with the help of this toggle switch, you can switch on and switch off the circuit with the help of this toggle switch. So this is the first operation, that is simply to on or off any particular device. The second is again it can be used for overcurrent, that is we have seen this thing with the help of bimetallic strip, and second is short circuit condition that we have seen with the help of this particular relay also. And the last one is the arc extinguishing device, which extinguishes the arc generated upon current interruption terminal for connecting wires and conductors. So whenever we will have a current flowing, and if we interrupt that particular flowing current, so arc will be generated due to the ionization of the air. So that particular arc has to be quenched so that there should be less wear and tear on the contacts. Now this is the figure for this particular MCCB. So as you can see, the size of this particular MCCB, it is bigger as compared to the MCB. So all these particular operating mechanism, then arc extinguisher, trip bar, terminal connectors, they were also present in the MCB. Now this MCCB are type of electrical protection devices that is commonly used for load current exceed the capability of MCB. So as I told you that basically MCB, they are used for household application, and for industrial application where the requirement is quite high, so we generally go for this MCCB. So more features that are present in this particular MCCB are, it has adjustable trip setting also, which is not available in case of MCBs. So adjustable trip setting means, suppose this particular MCCB, it is of 200 ampere rating and we want to use it for only 50 ampere. So there are different provisions that are present in this MCCB by which we can use the same MCCB for different current ratings. So they are called the adjustable trip ratings. Now again, the function of these are, first, protection against the overload, second, protection against the electrical fault, that is the short circuit fault, and the third most important function that can be used, it is for on-off mechanism. So again, you can see this, all these particular functions are also present in case of MCB. Now if you differentiate between this, so you can see here the abbreviation for MCB is miniature circuit breaker, for MCCB it is molded case circuit breaker. Now the tripping circuit in case of MCB is fixed, but in case of this it is movable. That means again we can change the trip rating, current rating of MCCB. Now it is again, both are available in single, double pole, triple pole versions. They are, both of them are available. Next important difference is the interrupting current capacity. As you can see here, there is quite a large difference between MCB and MCCB. MCB has interrupting this current rating of 1800 ampere, whereas MCCB it can go up to your 20,000 amperes also. So again, remote facilities only available in case of MCCB because they are used for industrial applications. The rating, again, MCB, you can find it, you can buy it from market from 6 ampere to 100 ampere. And this MCCB, if you can buy it for 200 amperes also, and with the help of current setting, you can check the setting from 10 to 200 amperes. So it has your different current settings, that's why the range is given here. So application, as I told you, MCB are generally used for household application, and MCCBs, they are used for industrial applications. So till now we have discussed about the three protective devices that are generally used for protecting any electrical equipment. But this fourth device, that is called ELCB. So this is electrical equipment that is generally used for the protection of human being or animals against the shock. So let us see how this particular ELCB works. So in this particular ELCB, we have a latching relay that has a structure of incoming main power associated through its switching contact, so that the circuit breaker detaches the power in an unsafe condition. The ELCB notices the fault current of human or animal to the earth in the connection it guards. If this particular voltage seems to be higher, then this coil will sense that particular level and it will give command to the circuit breaker and the ELCB will trip. So it will save the life of human being or animals. So here you can see in this construction, we have this particular coil. In this particular coil, it is connected to this trip coil. Now the first coil, it is connected here to the line side, and this particular line current is coming to this particular coil, and the same current, if it passes through the neutral, so the flux produced by both the coils, they will get cancelled out with each other. So that means the net voltage across this tripping coil, it will be low, so it will not sense any particular faulty condition. Now suppose by any chance, if this particular current flowing through the line, it comes in contact with any particular part of any electrical device, so under that particular condition, some amount of current, it will directly flow through the earth. So that means here now the line current will not be equal to the neutral current. So the flux produced by this line current and the neutral current, this will not be the same, and that particular residual flux, it will be sensed by the trip coil, and due to this particular voltage generated by this trip coil, this circuit breaker will operate. So under this particular condition, abnormal condition, that means if this particular live conductor comes in contact with any metallic part, then this particular ELCB will operate and it will save the life of human beings or animals who come in contact with this particular electrical equipment. So that's all for today. Thank you.